Okay, so I want you to add this to the notes you did from the video, but these are some extra things about group 1. So they're silvery, they're soft, and they are not found in nature as free elements. So I want to talk about why that might be the case. Why might they not be found in nature? Okay, what did I tell you about the number of valence electrons that group 1 has? They have 1. Okay, so here's what I want you to think about. For an element to be happy, be complete, it needs to have 8. It needs to have 8 electrons. Okay, and so for this group, they have a full shell, and then they've got 1 on outside of that full shell. Okay, does that make sense? They've got a full shell underneath, and then they've got 1 electron in their outermost shell. So their choices are to find 7 electrons from other elements or to give away 1. So what's easier? To give away 1, right? It's way easier to give 1 away than to find 7 more to bring in. So they are so reactive because they want to share their electron with anything that they can't even be found in nature. Right? They bond so quickly and react so much that they can't be found in nature. Okay, they are too reactive. Okay, they are most especially reactive with water. Okay, because they only have 1 valence electron. Okay, so I'd add that to your notes from that video, is that 1 valence electron that causes them to be super, super reactive. Okay, so reactive we can't find them in nature. Okay, I want you to watch this little video on this alkali metal, and it's not super important. I just think it's an interesting. Group 2, the alkaline earth metals. They have all of those elements. They behave a little bit more like traditional metals than group 1. They're more dense, they're tougher, just a little bit stronger than the alkali metals. They have higher melting points, they just have stronger bonds, they're just all around kind of tougher than group 1 metals. Okay? That in turn means they are less reactive, right? So let's think about group 1 metals. They had 1 valence electron. Group 2 has 2 valence electrons. So now their choice is either to give up 2 or to bring in 6. So give up 2 is still easier, right? So they react, but it's not as easy as giving up 1, right? So they're still too reactive to be found in nature because they can give up their 2 electrons relatively easily. But you still can't find them in nature, right? That's why we don't see chunks of just calcium metal floating around. Right? Do you think it's odd that calcium is a metal, knowing that our body needs that? Right? I think it's bizarre to think that our body needs calcium, right? We talk all the time about calcium. But you don't see chunks of metal floating in your milk, right? That wouldn't be good, right? But calcium, the way our body absorbs it, they extracts it from other compounds, right? The compounds that are in milk that contain calcium are absorbed into our bodies through chemical reactions that extract that calcium. So it's not just, we're not drinking metal, right? All right, so there's calcium metal. That's what it would look like in its most pure solid form. We obviously don't see that in our milk. Okay. All right, the transition elements, where are they found? Or the transition metals? In the 3 to 12. Yeah, 3 to 12, they're in the middle. They're that chunk in the middle. On our big periodic table on the wall, they're the red. They're the red ones. Don't forget hydrogen. It's a non-metal. I just didn't want you to forget. I just didn't want you to forget. Okay, it's the red. So they don't follow the rules like everyone else, right? It's groups 3 through 2. They have very typical metallic properties. Look at the transition metals and identify some ones that we're familiar with. That, like, when we think of metal, what do we think of? Gold. What else? Tungsten, iron. What else? Platinum, silver, chromium, titanium. Those are all things we think of as like true metals, right? And they're found in the transition metals. They are very, very typical metallic properties. Okay? So you don't need to write these down again. We already talked about metallic properties. Many of these do exist in nature as free elements because they are much less reactive than our previous groups. Okay? So they can be found by themselves in solid form, all that kind of stuff. Okay? they have a variety of valence electrons. They don't follow the rules of valence electrons like our other groups do. Okay? Next, your video didn't talk about group 6 or group 16, which is the chalcogens. So go ahead and write these ones down. Your video did not talk about these ones, but these are the chalcogens, and this is group 16, which contains oxygen. They are pretty reactive because let's think about their valence electron patterns. If I said that oxygen or these are in group 6, how many valence electrons do they have? 6. And how many do they want to have? 8. So now their choice is give away 6 or find 2. So what's their better option? Find 2, right? And so most likely they're going to take 2 from a group 2 metal and they're going to bond, right? Those are very, very common bonds that happen. But they're going to they're going to find 2. So they're still really pretty reactive. Okay? They have a wide range of properties. If you look up and down in group 6 or group 16, you will see that there are nonmetals, metals, and metalloids in that particular group. Right? If you look at your periodic table and the way you shaded it, you will see all different things. Right? You'll see nonmetals, metalloids, and metals within that group. Okay? So that means they form a wide variety of compounds. Right? They form all different types of compounds. They can be nonmetals, metalloids, or metal. Okay? So it's a very, very diverse group. Okay, so that's group 6 or group 16. I will most of the time call it group 6, okay, because I like the valence electron pattern, but I'll call it group 6 most of the time. Okay, the last one is that they can be man-made. So I want you to look at, let's see, your periodic table doesn't show you a difference in them. Let's see if mine does. Okay. So they can be man-made. There are only 35 man-made elements. I want you to look at your periodic table and see if you can find some elements that you think are probably man-made. Okay, first of all, write down this number, 35 man-made elements. You'll need to know that. Then take a look at your periodic table and see, can you find any that you think were probably man-made? What'd you say?
I don't know.
Yeah, Americium, Berkelium, Californium,
Einsteinium.
right, Einsteinium,
Lawrencium.
Yep. Mendelevium, Nobelium, right? All of these names that are clearly named after someone, right, rather than like an old Latin name, probably indicates to us that there is a man-made element. We obviously see that the periodic table I gave you goes farther than, let me see how yours goes. Yours goes all the way to 118, right? The one on our wall only goes to 115. It's out of date, right? The one that I have printed only goes to 109. Okay, so there's 35 right now discovered. Right, yeah, but this is one of them that's man-made. Oh. So I'm just going off of that to tell you more about it. Oh, but they're not all in group 16. You're right. Okay, sorry. Okay? So there's only one man-made element in that group. You are correct. But there's 35 total. All right. They have 6 valence electrons, like I said. Okay, I think your video went over the halogens. All right, they have how many valence electrons? What group are they? What group are they? 7, right? They're the next ones over. That's group 7 or 17. And as all of those, these are the most reactive nonmetals. Okay, this happens to be my favorite group. I don't know why, it just is. All right, that's my favorite group on the periodic table. They react in cool ways. I don't know, they just do cool stuff. They have 7 valence electrons. They usually form salts. Not that you need to really know the difference between different salts right now, but they can be gas, liquid, or solid at room temp. Okay, so if you look down group 17, sometimes there's distinctions made. Bromine is the one in that group that's a liquid at room temp. The other ones above are gases, below are solids. So they can be all those at room temp. They have 7 valence electrons. Okay, these are typically too reactive to be found in nature as well. Okay, because they have 7, how many do they need? They need 8, so that means if they have 7, they only need one more, right? Which means they'll take that electron from anything and everything and bond, right? So too reactive. These guys don't react with water. There's not a big explosion that happens with water for that group. Okay. Yep. Sorry. Yep. All right. So last group, certainly, but last but not least, is noble gases. They're group 8 or 18. They have all of those gases here. On our classroom one, that's the green column. They are pretty much unreactive. Okay, they're unreactive because they have all 8 electrons they need. 8 electrons means they have what's called an octet. So they have a full octet. Right? They don't need electrons. They don't want them from anyone else. They're unreactive. They are very much okay being by themselves. Okay, they are all gases at room temp. They have full outer shells. Those 4 are all technically used in what we call neon lights. Right? We call them neon, but it's more than neon that's used. Each of them emits a different color, and then mixtures of them will give us all kinds of different neon colors. Right? So we call them neon lights, but they are actually all of them used, which is kind of interesting. Sorry. Okay, so these are the last 2 parts. They sit below the periodic table called the lanthanides and the actinides. So on your periodic table, they actually do start with lanthanum and actinium on the bottom there. So you know which one's the lanthanides and the actinides. Those are the atomic numbers. The atomic numbers kind of actually change depending on the periodic table and where they stick those lanthanides and actinides, but that's not that big of a deal. They're very shiny metals. They're similar to group 2. There's not much you need to know about these. We don't work with the lanthanides and the actinides all that much. I just want you to know what they're called and know where they are. Actinides are the ones below that. All of these actinide series metals are radioactive. Okay, so they are a little bit different. They're radioactive. Okay. Some of these are found naturally on Earth, but a lot of these in the actinide series are our man-made elements. Right? If you look at the names of them in the actinide series, you'll see a lot of them are the ones we were talking about. A lot of them are those man-made ones. Okay, and both groups are placed below the periodic table just to save space. Okay, the periodic table is grouped by traits and properties and things like that, and so to save space, literally, they drop them below the periodic table. That's it. Okay.